Hello, welcome back. Okay, so this is the last one for the live stream. Not the last one for you guys of the show. That's still until 6 o'clock. This is an exciting one. John Wood-Elton, CTO at the Foundry, is going to be showing you the future, as we're calling it. It's a tech preview of all the stuff that we've been doing back at HQ with the research team and some of our commercial partners as well. I've been working with Framestore, Marada, a few other people, the Mill. There's a few people that we've been working out on this project. So John's available for questions, hashtag TFNAB. Also questions from the floor if you've got any. I can come to you with a microphone. So over to you.
Thanks, Bex. Hello, everyone. How you doing? How's your NAB? Yeah, good. Okay, so this is part of the show we call the tech demo. So the tech demo is really stuff that we're working on internally at the Foundry, so stuff the research team's doing, such that the engineering teams are doing internally. So it's stuff that we're working on. It's not something that's in a product yet, but it may well go into a product in the future. So 2 years ago, I did a tech demo of a thing we call Project Breakaway. And last year, we released that as NUKE Studio. So it takes us a few years, but eventually these things go out there. So what's the reason we do these tech demos? Well, really, we want to get feedback from you guys. So we want to sort of put our ideas out there, the sort of things that we're working out, and get feedback from you so that we can make that into the best possible tool to help you in your workflows. So that's kind of why we do it. The demo today is divided up into two halves. The first half is talking about AR and VR, because that's really cutting edge right now. Everybody wants to know how to do it, and everyone wants tools to help. The second part is asset management, and talking about how we're bringing asset management to be a first-class citizen across all the Foundry products. And I'll show you a bit of what we're doing there. So I'm going to start with AR and VR, the first part. And I'm going to go in a few definitions first, just so we're clear what we're talking about here. Because what is this stuff? What is AR and what is VR? So AR is augmented reality. So augmented reality is the real world, the world we're in here, mixed together with CG elements placed in there in real time. So an example might be, I'm in a fighter jet, and there's a targeting system targeting things, and there's a heads-up display, and you can see the targets coming up on the screen. Or another example would be, I'm sure you've all seen those apps where you hold up your phone, and you can see what the camera is seeing, and then you can see like, oh, there's a restaurant over there, and there's something over here. There's a map thing in real time going on your phone. Or another example might be virtual production. You're on set, you're doing stuff on green screen, and there's a real-time key, and we're putting CG characters in real time, and the director can look through and see that. So all of that is like augmented reality. And the Foundry is heavily involved in doing work in this area as well. I'm not going to talk about it today, but if you ever have time to go to Europe in 3 weeks' time, or is it 2 weeks' time, at FMX, we're unveiling some of the stuff we've been working on in a project called Dream Space. And it's about virtual production. It's kind of got most of the tech that we make at the Foundry thrown in together to make virtual production tools. So we got bits of NUKE in there, there's some Mari in there, real-time rendering, even Katana for aggregating all the 3D that go into the virtual production scene. So that's really interesting from the Foundry at FMX. So if you have time to go there, it's pretty cool. But today we're going to talk about the other bit, which is virtual reality. So that's a bit different to augmented reality, in that augmented reality, you're mixing the CG with the real world as you look around. But virtual reality, you're in one of these sort of things, and you're fully closed off from the outside world. You're internally in a completely virtual world, locked off from reality. A bit of reality is in you can move your head, and the world moves with it, but you're not seeing outside. Does that make sense? Okay. And on the virtual reality world, there's a few different ways you can make this content. One is like a full CG-driven engine, like a game engine-driven content. So you think about like a 3D immersive world in a game engine, like Skyrim or something like that. You can walk around everywhere in the world, and the game engine is generating the 3D content wherever you go. So you can imagine making a fully immersive world like this, where you put on this, and you have the left and the right eyes being generated out of this game engine. It's actually not that hard. It's the same as when you're in the game, right? You just generate the views as you look around. Hard to make a fully immersive 3D environment, for sure, but not that hard to translate that to the VR headset. The other way you can make stuff is doing live action VR, which is what the guys at Murata were showing earlier, composited into the CG environment, and what a lot of our partners are trying to do as well. So that is, actually shooting with a camera. So instead of having like one camera, like you would do normally when you're shooting a film, or maybe two cameras, like when you're shooting stereo, you instead have a whole ring of cameras looking in all directions. So remember when we were doing post for stereo, how much work that was? So that's 2 cameras. Imagine 14 cameras in all directions. It's a bit harder. So you can make live action content now with NUKE for VR. People are already doing it. Murata was showing you some stuff earlier. Other companies are already doing it as well. But what we're trying to do is make tools to make it easier for you to accelerate the process. And that's what our Ocular toolset was for stereo. We made making stereo easier. What we're trying to develop now is a toolset to make live action VR 3D panoramas easier. So that's what we call VR for NUKE. It's in development. It's not finished yet. We're just working on it. John Stark, our head of research, went around the world last year and talked to a whole bunch of different companies who are trying to make live action VR content and tried to find out from them what their biggest pain points are. And that's what we've tried to attack in this tool set that we're developing at the moment. So the main areas that they said to us they needed to attack were these areas. And I'm going to show you a little demo of each one of them to show you how we solved them. So I'm going to start off with the alignment problem. So what is the alignment problem? So when you shoot in 360, you have to make a whole ring of cameras looking in all directions. Now, when you make a 3D panorama with like a node-locked camera, it's on a single point in the middle, and you just sweep it around to take a panorama. So it's quite easy to solve the geometry for that because it's in a fixed position. In this ring of cameras, you don't know where they are in the world. They're not on a single locked nodal place. They're out in some ring, and there's also some parallax between the cameras. So you need to solve that to help with the stitching to make this dome later. So we're going to start with the alignment, and I'm going to show you a little demo of this. So this is footage kindly supplied by Framestore LA, and it's a 360 panorama of a beach scene, live action, with 14 cameras in this ring in stereo GoPro rig. So what we need to do first is find out the geometry of all these cameras, and that's what this tool does. Before we do that, I actually need to color match these as well, because you can see there's a color matching difference here because it's auto exposure on the GoPros, so I need to match the colors. Doing it manually in this case, but Ocular, the tool set we have for stereo, does automatic color matching, so we'll roll that in at some point. So I'm going to feed those images into the alignment tool, which we've got down the bottom. And inside the alignment tool, we have a kind of preview of what all the frustrums of the cameras look like when we do the solve. We also have a preset up the top, which is the rig that's used. In this case, 14 cameras, GoPro rig. There's other options in there for different types of rigs, and we will have like an unknown rig parameter as well. And then what we need to do is set a few keyframes where there's a lot of like corners or other things that the software can find matches on. Also in the future, we'll be able to add manual, just like Ocular, add manual correspondence points as well. And once we input all that information into the stitcher, we can, the alignment tool rather, we generate this. So this is the rig that came out of that, that solver, the alignment solver. And you can see it's a ring of cameras, stereo pairs, looking in all directions around in a ring this way, and 2 stereo cameras up, or 1 stereo camera up and down. Although the up and down cameras maybe are not strictly needed because stereo in VR doesn't really work in the up and down directions, and I'll explain why that is a bit later. Okay, so we've got the geometry of the cameras. So what's the next step? Before somebody asked later, yes, you could do this sort of thing in PT-GUI as well, but PT-GUI cannot solve for a geometry of cameras that's not on a fixed nodal point like I described before. So it wouldn't work so well for this case. Okay, so the next step is stitching. So we've got all those 14 images, and we need to somehow make them into a dome, a 360 dome that is our 3D world, right? But to work in the image processing land, we also want to take that 360 sphere and we want to flatten it out into a flat image called a lat-long image, which is like the sphere being slit down the middle, unwrapped, and then placed flat down on the ground, right? So that's what we're going to do now. So we're going to take the metadata, or all the information from that camera rig, and then put it into a stitcher node, rather. And you can see here that we're injecting that into metadata inside the NUKE stream. You could save that out, or tweak it, or do something else with it. It also saves us having to have 14 different camera inputs to the stitcher node. And then we feed those into the stitcher, and we also put a little bit of a fall off to decide on where the edges are going to blend. And then if we look at the output of the stitcher node, we have a preview of what the stitch is going to look like. Now, the preview of the stitch is just essentially doing the blending. But because these cameras have parallax, you can't just blend them together. They won't line up. So you can see there a bit of ghosting where it's not lining up. So what you actually need to do is warp the images together into each other. So we've got a lot of expertise in vectors and tracking where pixels are going. So we can warp the images so that they match perfectly. So you can see there we're warping. And if we look on the other side on the waves down there, it's being warped as well. So at the moment, we're doing the even side, which is the even camera, which is the left eye. If we do the odd cameras, that's the right eye. So now we have our stereo pair of a stitch panorama. Now, at the moment, I just did the ring around the middle. I haven't done the top and the bottom. I'm just going to show that we can do those manually if we want. I think when we do the final version, we'll have a thing that can do everything in one go. But I just want to show that we can also have some tools for projecting the images separately if you wanted to. So here we are creating the lat-long for the top. And we've got a tool for that. And then we're also creating a lat-long for the bottom. And then we're going to do a normal comp to merge those things in with a bit of an alpha blend. So that gives us our completed 360 panorama as a lat-long image for the left and the right views. You can see the rig is there. So this is one of the problems, obviously, with shooting in 360 panoramas. Where do you put the crew, right? Are the crew hiding in the boats, or, you know, I don't know. But you can't really hide the rig. The rig's there. The camera's got to stand on something. So, you know, so at some point, somebody's going to need to paint that out. OK, so we've got our lat-long image now. What's the next step? So next step is rendering. So earlier, Andrew from Murata was talking about the slit cam thing. So he did a lens shader for that for another 3D application. If we wanted to composite 3D inside of NUKE, though, we need the NUKE 3D image, 3D renderer to be able to produce images that fit into the lat-long. Make sense? So let me show you that. So why would you want to do that? Well, a lot of people use the NUKE 3D environment for doing set extensions, inserting CG characters into the comp. So we need to be able to render into that space to be able to comp it into the image. So what we're going to do in this case, I'm going to comp in a sphere into the image. It's going to have reflections on it. We're going to make a sort of the Flight of the Navigators kind of piece here. But first I'm going to show you some of the problems with the existing scanline renderer for doing this spherical rendering. So here's a checkerboard. We've just gone on a ground plane. I'm going to feed that into the scanline renderer, which is NUKE's internal renderer. And I'm going to put it into spherical projection mode, which is a lat-long projection mode. And we're going to see what the output looks like. So you can see the output looks, at the top of this lat-long looks not very good, right? It's a stepping problem. It's being distorted, right? So the reason for that is the scanline renderer is a rasterizer. It turns everything into triangles, and then it renders the triangles. The triangles, you need a lot of triangles at the top to get the warping correct, which means you have to turn the tessellation up really high. If you turn up the tessellation really high, it gets really slow, lots of memory. It's not really production ready. Another way you can get around this is to do a six-pack render, which is basically cameras facing in 6 directions in a cube formation, render out 6 different images, and then combine them together with a spherical transform. But that's expensive too, because you've got 6 renders, and then you've got 2 filter hits, 1 filter hit for the render there, another filter hit there. It's going to be blurry. So what we've done, and this took in a few years actually, but we've got a good application for it now, is we've written a ray tracer that you can have directly inside of NUKE, which means we can do any camera model we want. For example, we're doing spherical camera model here, And then for doing the stereo render, we're gonna do a slit cam lens model as well, just like Andrew did for another external renderer, because we can do that with a ray tracer, because we can bend the rays wherever we want. So great, we've got a ray tracer, we can now do that. We can now comp our sphere into the scene, into that lat long space. And I'm also going to put a reflection shader on it as well, because now we've got a ray tracer, we can do reflections. We can actually do ambient occlusion and other cool things as well. So that'll be good for normal compers. So let's have a look at what that looks like in the lat long. Set render. Now, it still looks quite round because it's directly in the middle, but it is getting distorted in this lat long way. And I want to show you that we can render more than just spheres as well, just because if you're technical, you know ray tracing spheres is really easy. So I'm going to swap it out for something else, just to show that we can do. Swap out for another thing. And you can also see that this is a Katana mascot. You can also see the distortion at the top as we go up to the lat long, just to prove that we can do it. But I think the sphere looks cooler, so I'm going to swap back to the sphere with reflections on it. Now, we did a little other tool here which makes it really easy to work or understand what's going on in the lat long image as well. We call it the sight, and what it does is it allows us to look in the comp as if we're looking through the rift. So it's like a camera model that unwraps that lat long and allows us to look through the camera as if we're looking through the rift. So it's really interesting because we can now look around and check out every part of the image, see whether the comp's working, see whether the render is working, and even see if the stereo effect is working. I'm just putting an anaglyph down the bottom there, but you could also output to your stereo glasses and see if that works correctly too. And there's a slit render again. We can adjust that to adjust the convergence for the render. And as I'll explain later, that sort of view with the sight where it's being flattened out could be quite useful for working in the lat long too, because you could imagine maybe working, painting in that flattened out space and maybe reprojecting it back onto the lat long. So here we have the final stereo pair, the left and right eyes sitting there, ready to go out to the rift or save out to a file. Okay, next step is compositing. So we did some compositing earlier, as in we composited the sphere directly into the scene. But what about if we need to do more things? What if we need to track something? What if we need to do roto? What if we need to do blurs or roads? That sort of thing. In the lat long space, in the middle of the image, it's quite easy because that's sort of flat. But up at the poles, it gets highly distorted. So how are you going to work in this world? Well, this is where it gets pretty speculative because this is really, you know, early days on this at the moment. But I want to show an example of what the guys have worked out back at the office, which is a blur that works entirely in this lat long space and correctly distorts depending on which part of the image you're in. So it's called lat long blur, its original name, and it's been built using a blank script, which is NUKE's internal language for writing image processing. And if we look at the point, this is showing us the kernel or the area of the image the blur is going to affect. You can see that as we move that kernel up and down the image, it actually starts to get distorted. So in the middle, it's round because there's no distortion. As we move it further up into the image, it starts to get stretched out. So that means that blur will be more blurry across the image than it will be in the center, which is what we want. And if we go to the edges, remember this lat long is on a sphere and it's getting cut and split open like that. So if we go to the edges, if it gets cut off, it actually needs to wrap around to the other side. So we look on the other side here, we can see this lat long blur is doing just that, wrapping around and working on both sides simultaneously. So I'm going to show you through the sight again what this looks like actually on the image to see whether the blur really needs to be weighted in this way and whether you can tell the difference. So if we look at the bottom of the image with the sight tool, that's the area where it's going to be the blurriest because it's towards the edge, towards the bottom, right? And I've got a little switch here to switch in between a weighted blur, the lat long blur, and a regular blur. And you'll see that one is sharp and one is not so sharp, right? The sharp one is incorrect because it should be more blurry than it is. Does that make sense? Okay, so it's early days with this, a lot of work to do, but we know we're kind of doing research in the right direction to be able to work on these lat long images in the lat long space rather than having to go back to some flat space. Another thing people try and do with this as well is try and rotate the sphere into a place where the image is the most flat, if you like. So imagine you've got the rig removal you need to do in the bottom corner. The bottom corner, everything's really warped. So if you're doing a roto, it needs to be warped. So what can you do to make that easy? You can imagine that lat long's on a sphere. You turn the entire sphere around so that the rig removal is in the middle, and therefore it's almost flat. You can do a normal roto with normal flat roto and then spin the sphere back. But every time you spin it, it's a fail to hit, so it gets blurrier. Okay, almost at the end. Review is the next bit. So it's all very well to have a look through the site and so on, but at some point you actually have to put the glasses on and check out what it's going to look like. So this is what we did as well. We basically added direct support for the ref from NUKE. So if we switch to the ref machine now, what we can do is, I've got this in NUKE Studio at the moment, but it works the same from the compositing environment in NUKE as well. We have a monitor out plugin, the same way that we can go out to SDI devices like Arja devices. We can go directly out to the Oculus Rift device and have a look what it's going to look like. So this is where we get to audience participation, because I've got only one Rift. It's going to be you, is it? No, we've got to pick someone. Who wants to have a look at this composite? Okay. So what you should see here is the entire image stitched together, the sphere in there as well. What do you think it looks like?
I see the ball coming towards me. And it looks blurry, but it's coming into focus, it looks like.
Turn around.
Yeah, I see a person there.
Cool. Does it look good?
Yeah, the girl's running to the person.
Okay. Okay,
Oh,
very
it
good.
looks great.
Excellent.
No like jitters when I turn my head, like I've seen somewhere.
Okay. Cool. We'll leave this here afterwards, so you guys can have a look afterwards. But audience participation, I can't give it to everyone in the audience, so we're going to do a little other thing so that everyone can at least join in a little bit. So can everyone put their finger in front of their face like this? And then those of you that can blink from left to right, blink left to right. Those of you who can't, just do this like this, okay? Now, what do you see when that happens? You see the finger going from left to right, right? Okay, so do the same thing. Tilt your head. I know it's going to hurt. And then do the same thing, right? Is everyone doing that? Now, what can you see now? The finger's going up and down, right? It's not going left to right. Okay. So this is one of the problems with doing stuff in a lat long space and doing it with the Rift without a game engine, is that when you've got this thing on, right? Remember we shot with 2 cameras and we had a left and right convergence. But in the Rift, you can turn your head like that, right? But if you turn your head like that, it'll still be offset left to right, those images. It won't be offset top to bottom because we haven't got those images. So that immediately gives you a headache. So you'll be like, oh, God, this is wrong, okay? But that's normally not that much of a problem because, I mean, how often you do that? Not that often, right? But what you probably do is exactly what you were doing, is look around and then maybe look up. And you could be looking up in any orientation. Remember the camera's pointing up? They're only in one orientation. So the stereo only works if you're facing in that direction. If you turn that way, it's going to be broken. That thing is incorrect. So stereo doesn't really work up or down, or if you tilt your head with this effect. So typically what people do in post is they fade off the convergence, so there's no stereo at the top and the bottom. Does that make sense? So it's a limitation of the format. Maybe one day we will have maybe a LiDAR scan of the entire environment, or some other method where we have more geometry of the world, and then perhaps we could generate new views as you move your head around. But we don't have that technology right now, and live with lat longs at the moment. Okay, go back. So that's audience participation done. So that wraps it up really for the VR stuff that we've been doing. It's really still in the research stage, in development at the moment, just like everything really in this field, to be honest. So we're actively looking for partners, people that are making content, people that experience these sort of problems. Yeah, so please come and contact me afterwards, and you know we can hook up with you. But this is really why we're exposing this tech now, because we want to work with people so that we can all make the best content possible for people out there. So that's part 1 of the tech demo. Part 2 is asset management. So you're like, oh, asset management doesn't sound very interesting. No, it is. It is very interesting, seriously, because what asset management is about for us is about really removing files really from the workflow. Thinking of files as not as files, but just as IDs or packages, if you like. So why would you want to do that? Okay, I'll give you a few reasons. One is maybe being at different locations. So everybody's trying to work in different locations now. Every time you have a file path, and you go to a different location and maybe you need to move that file. If you're in a NUKE script land, you have to go and rewrite all the paths in the script, right? So that's quite annoying. Or maybe you have some files that are in the cloud and some files that are local. You have the same problem. You're going to move these files around. Same thing with like communicating with different people. Like what if you're working on a particular backplate inside NUKE and you're up to a different version of the backplate? You know, you have to look for a new file. In an asset-based way, you can use a database to be able to move between those two files. So we really want to make assets a first-class citizen across the Foundry tools. So that's what we've been working on back at HQ, making assets deep inside the software work. So I'm going to show a couple of demos showing that. First of all, it's sort of a tech demo for internal at the Foundry showing asset management inside Modo and NUKE. And this is not the prettiest pictures because it's a tech demo. And then we're going to show what can be built on top of this, which is ftrack and what they've done inside NUKE and NUKE Studio using this asset system that we've built. So let's start with Modo and NUKE, assets in Modo and NUKE. And we're going to start off in Modo here. And as I said, not pretty pictures because the engineers built this. But I'm going to render out this image, and instead of saving a file, I'm going to publish it as an ID, as a reference. I'm going to call it shot9, publish that guy out. I'm going to go back into NUKE, and now load in that image for compositing. And now when I bring up the file browser, I actually have an asset tab that has that asset in there. And I can bring in that asset without referring to any files. Right? I'm going to go back into Modo, and I'm going to render out a new version of this. I'm going to make it different color, kind of rose gold. It's quite on trend right now, rose gold. And save that out as another asset. Same asset ID, but a different version. So I'm going to call it shot9, and I call it new version, and EXR 16-bit. And I'm going to swap back to NUKE. And instead of loading it again from the file system, I've got now an asset tab. And you can replace that with an asset ID. And now if we look at the file path up there, rather than referring to a file, it's now referring to some asset ID that we can replace with anything we want. We've also integrated that asset browser tab into the comp part of the browser, and also if we swap back to Modo, integrate it into the Modo part of the browser as well. So this sort of widget, if you like, is a really basic one that we use internally for testing. It's not very pretty, but anyone out there, like your own studio or say ftrack or Shotgun, could integrate their own widget into that. So I'll show you that right now, what ftrack have done to really build on top of this integration. It's not for Modo yet, for NUKE and NUKE Studio, but Modo will be coming later. And this demo is really great, as in it really builds on the collaboration in NUKE Studio as well, and makes it even better with asset management. So let's have a look. We're in the timeline. This is a normal sort of thing you might do in NUKE Studio, is have a whole bunch of shots in there. You need to do compositing on there. So what I'm going to do is assign an editing task and a compositing task to each one of those in the timeline. And then I'm going to use the ftrack system to publish this to the database. And that's going to make assets out of all of the things in the timeline. So it gives us a little preview of all of the different tasks in there of what it's going to do. And if I hit export, it's going to go off, publish all those shots, make assets out of everything. It's also going to generate a whole bunch of thumbnails that later our producer could look at when they're in the web interface, for instance. So let's have a look at the web interface now to see what we've got in there now that we've published. And you can see there we've got all the different edits in there and all the tasks that have been put in. And also if we go to the versions tab, we've only got one version, but this will show us the first version for preview. Now I'm going to swap to NUKE. You've got to imagine I'm another person now, Jack Binks, who's working on this composite. No, rather, Ben working on the composite. And what he's going to do is go to the asset tab like I had before, but now you can see there's a full ftrack thing in there rather than our crude one that I showed earlier. So now we can open up that asset. Again, it's got an asset ID instead of a file. And I can make some modifications to this and publish that back as a new NUKE script that maybe we could pick up in NUKE Studio as a supervisor. So let's look at that. I'm going to make it an annotation. And also, this is quite cute. A little screenshot of the node graph so that later when you're looking in the asset system, you're like, oh, I remember that node graph. Or maybe as a supervisor, you could go, you've been really messy. You can clean up your node graph. And we go back into NUKE Studio, and we've got a tab here that says Ben has been working on that shot. And now if I try and open the same shot from NUKE Studio, we know that there may be a clash here because we're both working on the same shot. Now with this integration, ftrack tells me somebody else is working on the shot, don't go and modify it right now. But I can send a message now back to that person who's working on the other shot with this crew tab here. So I'm saying, why are you working on the script? You weren't assigned to it. And Jack, let's see what happens to Jack. Jack is like, oh, we got the message. And he's going to send a message back saying, I thought I was supposed to work on it. Let's have a video call to discuss it, because these guys are in different offices, one in LA, one in Amsterdam. So there they are. That's Jack up there with the beard, Ben with the no beard. Okay, so we've done that. Now we're going to assign the task to Ben so that we don't have that clash like we had before. And then I'm going to back to Studio, and this is pretty cool, I'm going to update this backplate. So that backplate is already published into that NUKE script, and he's in Amsterdam working on that NUKE script separately. What if we had a new version of the backplate that we need to push into all the comps? Well, we can really easily do that as well. We're going to publish this new version of the plate, and then go back into the comp, and he gets a message here saying version 2 of the plate is available. So he knows that there's a new version, and now he can just update that version by hitting reload, and there's a new version of the plate come in. So this is why the asset IDs are good, right? You have all those versions stacked up just by having that abstraction, if that makes sense. And it's cool to see that, a third-party vendor can really build their asset system really deeply into the Foundry applications. So that's it from me. I have no more. Thank you very much for your time.
You guys have been busy.
Yeah.
I have some questions about the VR, AR stuff.
Okay, yeah.
All right.
Shoot.
First of all, when you reconstructed the virtual rig, you can see all the cameras there.
Yep.
When you guys first started doing that, you started seeing the results. How close was the virtual rig to the actual physical hardware if you looked at the two?
Yeah, they're very close. Otherwise, the things won't line up. So yeah, that's what it's for. Like, because we find all the correspondence points for all the things. That helps us to solve that. So if they weren't matched up, the stitch wouldn't work, and you would know. Yeah. Yeah.
I mean, you see those like the jaunt rig and these VR. It's a crazy big ball of cameras.
Yeah.
So that leads me to my second question. You sort of touched on it briefly when you were talking about other systems like PT-GUI that will take a sequence of images and turn it into a pano, but they need to be node locked or to the center locked to the pivot point of the camera, basically.
Yeah.
And I don't know how many people are familiar with that, but basically, if you want to give a quick rundown of how like a nodal ninja or something works versus the jaunt, because it's a crazy maths problem that you guys have solved.
Yeah, absolutely. So yeah, there's just a difference there, because on the nodal position in PT-GUI, it's spinning around a single point. You're actually shooting one shot at a time, right?
And you have to know on your camera which lens you have on the camera.
Yeah.
And you have to get the camera on the tripod exactly right, balanced on the nodal point.
Yeah, and then because it's balanced and it's frozen in time, you know that it's not going to change as you move the camera around. Whereas this rig, because you can't have a camera facing in all directions and be completely, if you could have such a thing, which they did have in the olden days, a camera that could spin really fast this way, then
I
you
see
could
them on Google cars all the time.
Exactly, yeah. If you spin the camera very fast that way, you could imagine you could capture the entire panorama at once. But
Well,
That's a
at
difficult,
once.
yeah, it's still not at once. There's still a time delay.
Yes.
So anyway, I dive.
Now you need to do two of them.
Yeah, no, you do.
In the same space.
Exactly. So yeah, so you need to put the cameras on a rig. They can't all sit on top of each other, so they have to be offset by this amount. And yeah, we've done a lot of work on the maths and so on to work out, where in space they're positioned off from that nodal center point.
And then the other thing I wanted to ask is, was when I talked to Andrew about this as well a little bit, but the little bits of cleanup and the little bits of roto, when you're trying to do that, are we able to repurpose a lot of the tools that were built in Ocula? Did that translate
Yeah,
straight
definitely.
across?
Like, there's a lot of tools in Ocula that will come across to this tool set, like the vector work we've done. Obviously, color matching is something that we'll need to do. We have tools for matching the zooms on the different lenses, stuff like that, because that's all the problems we have with stereo. Now it's multiplied by a lot of times, so all of that is really useful. But when it comes to doing roto and doing roto and paint and other like tracking and all that stuff in this spherical world, it really is early days. There's nothing in Ocula that can do that. So this is something we need to kind of put at the base compositing level of the NUKE engine to be able to do it. I mean, other ways around it is the way that I described before, trying to unwrap it and putting things in the center. But yeah, that Gaussian blur and the lat long space is the start of what we can do with the technology we have at the moment.
Well, and your demo of the Gaussian blur I thought was really good because it made the point. But then I started thinking about, wait, if you're blurring that side of the image while you're blurring this side of the image, then when you go to blur that side of the image, are you double blurring? And how do you account for the fact? How do you?
Yeah,
right. I mean, visually it seems. Oh, yeah, I see how you do that. And then if you just scratch the surface a little bit, you're down the rabbit hole.
Yeah, it's quite tricky. But you can imagine it's not that tricky if you think of when you're on the edges. If you joined the sphere back together, spun it around into the center, blurred that, spun it back, and then split it apart, that's essentially what you're doing, right? Except you just have to do it on the edges. So if you think of it that way, it's not that complicated, I think, right?
I have one more.
It's
and
still
then
tricky in terms of math, but
right,
yeah.
exactly. That's the thing. And all this stuff, you look at it, and then you think, wait, someone used math to do that. It's crazy. It's just typing. It's just typing.
Just typing. A lot of typing.
So the other question I had for you is the technique of using stand-in geometry and then projecting on that geometry.
Yeah.
Is that relevant here? Could you use that
absolutely.
for some of these things?
Yeah, definitely. Like that would be a possible way that you could generate views from many different directions, right? Because that's essentially what they do when you're doing post-conversion for stereo. You just shoot one eye, you roto everything, and you either do a depth grade with a roto, or you making stand-in geometry and project it onto the geometry and then render from another view. So you could do a similar thing with this, but generating stand-in geometry is not. You have to make a lot of geometry. It's not easy to make geometry. If the world's really complicated, it takes a lot of man-hours to make that stuff. So,
And does all of this process? I mean, aside from the obvious reasons, but when you start moving that rig around,
yeah, that's another problem entirely, because there's a whole bunch of issues there that we haven't even dealt with. I mean, there's a whole issue of stabilization as well. Like, how do you stabilize the whole ball? And then, yeah, moving rigs is another thing that we need to look at as well.
Yeah, because when I was watching, I was thinking, well, maybe you could do a point cloud. Then I realized, oh wait, no, you have to move the camera around to get the point cloud, and that's going to be challenging.
Yeah.
But yeah, if you had some modeling, I guess you could model in basic shapes like Grant was doing earlier.
Yeah,
so.
exactly. Yeah.
All right.
So this is. It's all challenges, but it's all very exciting because nobody exactly knows how to do everything. So, everybody's learning at the same time, and this is why we really want to connect with guys out there who are trying to do it and make sure that we're all in the same direction so we can make the best possible tools out there.
Well, and this is I will continue to toot the horn of the R&D team and the HPC and the NUKE team, but I think this is one of the things that makes the Foundry special is that we're out on that bleeding edge. We're constantly pushing. Yeah. So, we're very attentive to what users want, but then sometimes we have to go out and get out a little ahead of things so that we can then say, well, I think we can solve that.
Yeah, exactly.
Bex, do we have questions from the intertubes?
We do.
Hope they're
Best comment ever.
Really?
Yeah, I'm just going to do the comment and then I'm going to go into the questions. This was at the beginning. Take your protein pills and put your helmet on. Ground control to Major John.
That's terrible.
It's awesome.
That's great.
We were just really laughing.
know really what it
Okay,
means.
so now I have some serious questions for you, mister.
All right.
It's nice being at this height, isn't it?
Yeah, you
This
look
doesn't
taller.
happen. I look taller. I'm on a box. Have you any plans to replace the scanline renderer, potentially with some Modo goodness?
Yeah, so when you saw the demo earlier, that we've replaced well, we haven't replaced it. We have the scanline renderer and we have the ray renderer now as well, which is a ray tracer that we're having in NUKE. And we have most of the shaders done. We can do ambient occlusion. We can do different camera lens models like I showed you before. The shadows are much better. It's actually really fast as well. It's actually faster than the scanline renderer, especially when it comes to big scenes, and the motion bursts faster. So that's what we got.
Good. There's been a lot of nice feedback about the Modo NUKE integration. Lots of
Yes.
happy people about that.
So we do have that coming up as well, Modo
Okay.
NUKE integration, which
So
hopefully I can release at SIGGRAPH or something.
Yeah, I mean, the asset-driven stuff is really cool, and I think
Yeah.
maybe what people are talking about, seeing that ability. But then there's other
Yeah,
other
we'll-
secret nodes that are in the works.
Yeah, we also, I mean, I think we've shown a
We
tech
have shown
demo
them.
of the Modo, the output of Modo going into NUKE. So we're working on that as well to make the workflow even better. We can do stuff like have multiple passes coming in. We can send the camera back to Modo. We could do stuff like have a transform in NUKE that moves the Modo scene around, but then send that back to Modo so that you can do your final render, stuff like that. So that's all coming. I didn't have time to fit it into this demo, but it is coming.
So, this is from our friends.
Alex Fry, he's going
Alex
to ask me a really
Fry.
hard question.
I was just like,
Go on.
yes. Are you looking at tools for analyzing, idealizing lens distortion for fisheye lenses? Grids don't scale beyond a certain point.
So he's asking me hard questions. I'm not sure if the team are looking at that. They probably are looking at that, because if that's one of the problems that you've got here, then I imagine we need to do work in that area, Alex. So I will ask Dr. Stark back in HQ.
You heard it here, Mr.
Yeah,
Fry.
I'm looking at you, Fry.
Mr. Fry. Okay, John, is there an ETA on these great new NUKE tools?
So there is no ETA. We have no direct plans to make a product out of it, to tech demo at the moment. What we do want to do is probably get it out in some form as an alpha or something, so that we can work with partners to hone the tools.
It sounds like if someone really has a project that really needs it, they should be talking to you, because
Yes,
we need usage
absolutely.
cases anyway.
Yeah, that's exactly. We need footage, and we need partners to help make these tools the best they possibly can.
So they can prove they need it by sending you the footage.
Exactly. If you've got footage, you've got a high chance that you might be able to get your hands on some of this stuff. Is that
So
blackmail?
That's a pretty good
Sort of-
gating factor right there. If you have a 14-camera rig
Yeah.
already capturing footage, talk
Yeah.
to us.
And if you've got like your own custom rigs and stuff like that, that's really interesting too, because, yeah, interesting. And
So
if you're
that's
shooting
all
like
on
with
this-
like real, not real, but like cinema cameras as well, like a rig of Reds or a rig of Aries or something, that would be really interesting.
So that's all from this side. I think we're done.
We're done.
Okay.
We're done. So I just round of applause for Mr. Wood Elton, CTO, the Foundry.